All right, good afternoon again, folks. My name is Omar Bimji. I'm the Sustainability Services Manager for SES Consulting. The folks at ZEBx have asked us to facilitate a few lunch and learn sessions over the coming months, sharing what we here at SES and some of the people that we work with and collaborate with are up to, and what we're learning that can help move the practice of building decarbonization forward. With that said, we do have several folks from ZEBx on the call, and they may be jumping into the chat from time to time, folks that you're all pretty familiar with. So today we're going to be looking at the Atrium building and one of the first commercial projects to replace a heat pump with a heat pump. Jal Properties, the owners of the Atrium, and our team learned a lot about optimizing these kinds of systems, and we're excited to share our learnings with you today. So joining us today are Jason Finster, who is Jal Properties' in-house energy manager. Jason is a certified energy manager with over 10 years experience overseeing and improving energy performance for Jal Properties, a developer, owner, and manager of premium commercial real estate over on Victoria Island, BC. Jason's co-presenter today is SES Consulting's very own president, Brad White. Brad's a professional engineer with over 15 years of experience in energy efficiency, low carbon technologies, and smart building systems. He's demonstrated a passion for the sustainable use of energy throughout his professional career. This passion continues to drive his work today, and I'm sure is going to shine through in his presentation. So with that said, I'm going to turn over the microphone to Jason and Brad. They're scheduled to talk for about 40 minutes, which should leave a good chunk of time at the end for questions and discussion. But please feel free to pop any questions that arise during their presentation in the chat so that they're not forgotten. So Jason and Brad, I will turn things over to you.
All right. Thanks, Omar. So if you want to go to the first slide there. So as Omar mentioned, I work for Jal Properties. We're we develop, own, and manage the office buildings here in Greater Victoria area. We built the Atrium building. So the Atrium, for those of you who aren't familiar, the Atrium building is a building downtown Victoria, has 6 floors of office space, ground floor retail, and it's about 220,000 square feet. Another fun fact, this office is it's home to BC Ferry's headquarters. It also has their operations center operating out of there 24 hours. As with one of the primary, they operate sort of half the office space there. This building was a big leap forward for Jal Properties in terms of our commitment to sustainability, as it was our first LEED certified building. And yeah, this one was so right from the get-go, there was a lot of sort of sustainable features to this building. One of them being that it's served by a heat pump. It's 100% electric, which was a choice we made right away before my time. So getting right into the original mechanical system, I can skip a slide here. So the original HVAC system for this building is a air-to-water heat pump with electric boilers as the backup. Then it has a variable air volume system with hydronic reheat coils downstream. This heat pump the heat pump system was a first for us, and I believe a first for most of the places most of the lower island, at least back in 2010. So there was a lot of sort of learning curves with this sort of a system. I can get into the performance now. So if you want to skip the system or skip the slide. So being that this was a new system with a lot of unknowns at the time, everyone was sort of, there was a lot of it was hypothetical. It was sort of a bleeding edge sort of a building. And the original system performed well in the shoulder seasons, but we found it couldn't keep up with higher demands in sort of the peak of winter, peak of summer. And luckily Victoria has a lot of shoulder season, which is great. However, unfortunately, we'd have to run it about 18 hours a day, even in the shoulder season. And then 24/7 sort of a system in the winter and the summer, just to keep up, because we were finding that in the summer, obviously it was getting too hot in the building, and we just had to keep running. In the winter, we were finding it was getting too cold. We also had many issues with equipment breakdowns and the system underperforming expectations for this building. And then the issues one of the big things in this that we've learned from heat pumps was flow requirements in the early days for air source heat pumps were sort of misrepresented and poorly understood at the time. So by no one's fault, it was just sort of yeah, the nature of the beast. So issues kept compounding until about 2021 when we were informed that this heat pump had kind of reached its end of serviceable life, and we wouldn't be able to keep kind of band-aiding the system together. And yeah, no, it's sort of so the system had sort of an 18 to 24-hour runtime for 11 straight years, which it doesn't seem like a good lifespan for a heat pump, and we certainly expect more from the newer ones. But that much work on any system with little, yeah, that much work is gonna wear on things. So
Jason, do you just want to talk about the controls issues for a
yeah,
second too?
yeah, sure. So yeah, thanks, Brad. So we had a lot of controls issues with these. As if anyone's worked with an air source heat pump or air to water heat pump, there's a lot of there's sort of a black box of kind of there was a lot of controls issues. We would sort of say it wants a certain thing, and then we would say we want this coming out of it, this water temperature coming out, and we would provide it with what we think it needs, but we don't really know what it does. Is part of the gist that I understand anyway. So after much trying to make it do what we want, we ended up actually ripping out the controls of the unit itself once it was outside of its warranty period, and replacing it with a Delta setup that then we can kind of actually control things a little bit more succinctly ourselves, which led to much better performance out of the system. However, we still had issues after that. Brad, I don't know if you want to chime in on any of the performance issues as well, or
No, I mean, I think you covered it. You know, a lot of it came back to the original design, and I said, you know, I think to your point, I think there wasn't so much, you know, anyone did it wrong or made a mistake, as it were. I think it's such that there just wasn't good information available. I mean, sort of the story, as I heard it, was the manufacturer themselves didn't really communicate or even understand necessarily what the requirements for their own equipment were, specifically in terms of flow. And I think what you found was, I think particularly on the heating side, you didn't have nearly enough flow through the units. So compounded with long run times, there are other issues caused by low flow, which are really hard on the equipment over time.
Yeah. So agreed. So in this project, so this was a really unorthodox project because in most of our other buildings, we're looking to upgrade to a heat pump, but in this case, we already had a heat pump and we just wanted to make it better, and make it last longer than 11 years. So so if you want to skip slides here, Omar. So our project goals, top priority is occupant comfort of the building, make our tenants happier. So all of our office tenants are original, and they've been through all the ups and downs with us HVAC wise, and we owe them something better. So, so that was our biggest goal here. The second priority is reliability of equipment. We do not want a repeat of our last heat pump experience. And then resiliency. We were looking for something with reliable cooling and the ability to handle extreme weather events, and some redundancy for inevitable breakdowns would be great. So
these design discussions were taking place in the immediate aftermath of the heat dome. So I think that was very much on everyone's minds at the time.
Definitely. That was very top of mind of how, if these heat domes become a more regular thing, how are we going to deal with it? This building in particular got up to about 30 degrees, which is not the most comfortable. So, but yeah, so we're looking for ways of achieving all of this, and then on top of it, energy savings, because who doesn't love to save energy? So energy and then emissions reductions, which come with them. But this being an all-electric building was, we benefit from that. So the emissions are not too high here anyway. I'm going to skip to that. So the origins of the project were, it was clear that this isn't a simple like-for-like replacement. This isn't the sort of thing that you can just sort of put out to tender and say, hey, we have this, we want this, let's swap it out. So given all the unknowns on a retrofit project like this, sort of a collaborative approach seemed like the best option for us. As a corporate philosophy, we've always fostered relationships with trades and consultants. So we have some really good trusted relationships with a lot of our trades and consultants we work with, that we've worked with for like SES alone for over, I think, 18 years or so, something like that. And same with the service contractor that services this building has been over 30 years. So they've been there since the beginning. We have a very good relationship there. So, and yeah, being owner operators also gives us some flexibility in how we award work. So we've worked on sort of bidding the job. If it makes sense to tender the job and just have a straight up bid, then we will. But if it's complex with many unknown variables, then design build seems to be the best way to go for us. And we've often found, at least on the operations side, the design build actually ends up kind of saving us a lot of money in the end, because otherwise people are sort of baking in um, a lot of contingency for themselves to uncover these unknown things. So step one was we talked to the contractors on site in our time, and which is Island Temperature Controls is our service contractor here. So we started looking at them and we said, okay, what issues do you see with the building, and how can we do better with this replacement? Then and we had conversations just one-on-one with them for the bit, and then we decided to bring in a consultant. In this case, it was SES. They were there. They sort of did some energy consulting on this building, energy models in the very early days, and then hadn't seen the building in many years, I think, as far as I know. But in the meantime, we've worked with SES on many different energy audits and COP studies and all sorts of things over the years. So, and I've had a really good relationship with them, so they made sense as a good partner for this project. Yeah, and then so the early days of the project consisted of sort of the three of us, SES, JOL, and ITC, sort of meeting regularly, sort of download the past issues of the past 12 years, and then kind of give our laundry list of complaints, our laundry list, and then our list of desires to SES, and then they can sort of come back with a plan here. So, which I think is what Brad is going to chat about now, right?
Yes, I believe so. Yeah, so sorry, the folder just popped up there.
Oh,
Yeah, thanks, Jason. I think you covered a lot of the background really well. I want to take a minute just to kind of end before we'll talk about, I see a lot of technical questions in the chat there. I think we'll address most or not all of them as I'm talking here. But before we talk about the technical piece, I do want to kind of emphasize this sort of unique project arrangement, because I think as engineers, we're used to working in under CCDC2 contracts, and a design bid build is the way things go. And this was a very different approach, where, as I said, we've got this long-standing relationship with JOL Properties. We've also worked with Island Temperature Controls. I think I was telling Jason, this is even before Jason joined JOL, but the very first project I ever did as a consultant when I started with SES was in some of JOL's buildings and working with ITC, and that goes back, I think, 2007, 2008. So that's how long some of these relationships have been around. But this was certainly the most complex thing we'd ever kind of attempted to work with them. But I think from day one, JOL had kind of pulled together their preferred team, which included, I think we were doing the mechanical, and they had a preferred electrical contractor, ITC, and then ITC brought in some other trades to do the piping and such. And everyone was around the table from day one. So as we were doing the design process, we were talking to the contractors on a regular basis, bouncing ideas off of them, getting their feedback on the design process. And I think what we found is that made it way more efficient for us. We were kind of guessing at less, making fewer assumptions. The project saw, it was not really a fixed cost contract, but there were much fewer changes as the project went on. I think we were able to get going much faster. I think this was all, again, taking place. And I think I maybe advance to the next slide there, Omar, because I think we've got some of the project timelines on the next slide. Because so this, again, the timing of this project, if you cast your mind back 2 or 3 years, was in some of the in the midst of post-COVID supply chain constraints. So we were ordering kind of 2 very big pieces of equipment. We had to order a chiller and we had to order a heat pump, and they both had like 30-something week lead times. But we were able to get, because we were working very closely with contractors and the distributors, we kind of got that piece out of the way first. I think we even had some unique arrangements around the equipment. I think JOL bought, if I'm correct, Jason, you guys bought the chiller and the heat pump yourselves, rather than having the contractor purchase them. Again, that was just to speed everything up, and the contractor did the install, and that required some conversations about making sure the warranties could still be honored and all that. But we got through all that. So all that to say, and a lot of that was around trying to navigate these supply chain constraints, and because obviously we wanted the equipment in place, and particularly the cooling in place for the summer was kind of the driving thing. We had electric boilers we could use for winter if you needed to, but the chiller piece was kind of the crucial piece. So the whole project schedule was revolved around that. So I just want to emphasize how much, as from the consultant's perspective, we enjoyed working in this integrated environment. And how much easier it made kind of the whole process, just having the contractors there, because and especially ones that knew the building as well as they did, because they were able to help us with placement and piping layouts, and just let us know what was going to be easiest for them, and from a designer's perspective, fantastic. And I think we actually ended up using way less time than we expected. I think we had provided Joel an initial consulting budget, but sort of did it on almost a time and materials basis, and actually didn't end up using uh, anything close to kind of the overall amount of hours we expected we might need for a project this complex. And I think a lot of that is back to having this great team there kind of from day one. You want to keep going, Omar? Next slide. So in terms of the overall project scope, I don't know that we actually kind of fully covered this, but we're taking out the old air source heat pump, and the old air source heat pump was doing both the heating and the cooling for the building, with the electric boilers doing the backup and peaking. So we removed that. We had to install all new heating and chilled water piping. Chilled water piping was not in bad shape. It was kind of the right size. So we didn't have to do as much work there. But on the heating side, we basically had to redo all the pipe. The diameter of the old pipe was way too small for the volume that we needed for the new equipment. So, well, and the old equipment, quite frankly. So all of that had to go. And I think that the piping ended up representing what was like a third of the whole project cost, Jason, I think.
I believe so, yeah.
Yeah. So that was an expensive thing to have to correct. But I think everyone kind of agreed there was not really any point in doing the project if we weren't going to fix that. Because I think that's quite frankly why, originally it had been done, and I think in the early days realized, oh, we got a problem here, but it was just deemed too expensive to correct. But I think at this point, I think everyone had kind of had enough of that arrangement, and decided that now was the time to actually fix that correctly. So we did, all new piping. We installed, again, heating and chilled water buffer tanks, which were not part of the previous design. And again, if you know anything about heat pumps, system volume is an important consideration. So just having enough water in the building, and there just wasn't enough before, which again contributed to equipment issues. Mainly that contributes to short cycling more than anything else. So we added new buffer tanks. Again, that's relatively expensive because you got to find a place to put these. I forget exactly how big these ones were, a few hundred gallons at least, if not more. And so you had to build a structure to put them on, find a place that has enough structural capacity to carry the big tanks full of water, very heavy. So this is all up on the roof. Installed new air source heat pump, and we did an energy study prior to the design, which kind of proved out the merits of heat recovery. So being able to operate the heat pump, doing heating and cooling simultaneously, and do some internal heat recovery within the equipment, which just effectively allows it to operate at a higher efficiency. So we included that as part of the equipment, and then we did a separate high efficiency chiller. So again, in the aftermath of the heat dome, the fact that this building had consistently had cooling problems, Joel decided they didn't want to take any chances at all with cooling. So we have kind of a full high efficiency chiller that we operate in the summer to do the cooling load. The heat pump can do cooling, but it really only operates under normal circumstances in cooling mode during the shoulder season, but does have the abilities, like if the chiller was ever to go down, we could run the heat pump in cooling mode as well. And I guess another thing to reflect on, just again, with what's happening after the heat dome, part of the conversation we had during the design process with Joel was, well, at what temperature do you want to be able to keep this building comfortable? Because design temperature in Victoria, I think, is for cooling, it's like 25 Celsius or something. It's not that hot. So we actually had a conversation about, well, okay, we assume we want to go higher than 25. How much higher do you want to go? Again, I forget exactly the number we decided upon, but I think it was something like 30 or 32 Celsius to say that, when it is 30 degrees Celsius outside, we actually want the building to still be able to remain comfortable. And that was actually the information that we used when we sized and selected the equipment rather than designing to sort of design conditions. And I think more and more we're having these conversations with owners. It's like, well, what do you actually want your system to do, and how do you want to perform in different circumstances, rather than necessarily going off kind of the code minimum or the standard kind of ASHRAE design practices. I keep going, Omar. I'm probably taking more time than I should. There were some questions in the chat about, I know it's about heating and cooling load, and how do we figure that out? Well, because it's an existing building, we actually had the benefit of using data from the BAS. So we did take, this is obviously a very simplified version of it, but we did take long-term trend data of pump, and we had pump flow rates, and we had supply and return water temperatures. So we used a lot of that to get a sense of what the heating and cooling load in the building actually looks like under most circumstances, and then sort of map that out against outdoor air temperature, which you can see here. We did do traditional sizing as well, using, I think we usually use Carrier HAP software, which you kind of put in all the building parameters and the glazing percentages and all that. And so, kind of it's a check against the numbers we were getting out of the BAS. But those proved to be pretty good. And so you can see here, sort of between 10 and 20 degrees is a pretty good overlap of heating and cooling loads. And just, Omar, if you want to advance to the next slide. So that's looking at demand. The next slide. Oh, did we lose a slide? I thought there was another slide. Okay, that slide disappeared. Anyway, it's Victoria. So between 10 and 20 actually represents I don't know, probably half or more of the whole operating hours of the facility. It's, that's a lot of the operating times between 10 and 20 degrees Celsius. So that gives us a lot of window to do heat recovery within the building. And there actually were, because the building was designed kind of with high efficiency in mind, there actually was an air side heat recovery system put in on just kind of two big air handling units. They had the ability to recover the heat from the air handling units kind of before it was exhausted from the building. That was typically never used because it actually overheated the supply air going back into the building. So when we looked at the building, we realized actually if we were to start using that again, and then instead of using outdoor air, we used chilled water to control supply water temperature, we could actually recover that heat back into the system and then put it into the heating, which ends up out the VAB reheat boxes throughout the building. So that kind of helped us make the case for the energy, because the heat recovery upgrade, I forget how much it was. It was about $80,000, $100,000 kind of thing. I think, Omar, we kind of lost the slides there.
Sorry about that. I will bring them back.
But yeah, so and that actually there was an energy study, and we actually did get some funding from BC Hydro to upgrade to the energy to do the heat recovery piece, as well as a high efficiency chiller. So there was some incentive funding provided for that. Yeah, you can keep going. Yeah, so to talk a little bit more about the equipment selection. So we spent a lot of time on sizing and selecting equipment, as you can imagine, just because of especially all the problems they had. We really wanted to make sure that we got it right. Had lots of conversations with the supplier, trying to find as much information as we could beforehand. But there were still surprises. And so just a couple highlighted here is the equipment ended up having a bigger pressure drop than was in the literature. And as anybody knows anything about design, pressure drop contributes to flow. So obviously your pumps are designed for a certain pressure drop to achieve a certain flow. that pressure drop is bigger than expected, you actually need more pump energy. We had been very conservative with pump design, and actually, I remember one meeting with the design team, and we were sort of on humming and hawing about how big to make the pumps, and we actually ended up going the decision to kind of go a size up, just so that we would never have any issues with flow because it was it played such a role in sort of the problems the building had been experiencing up to that point. And then we had speed drives, so we could kind of dial in the pumps where we wanted. So because of that decision, and I want to say that was foresight, it was probably as much luck as anything else, that we were actually able to handle that increased pressure drop by just we're using more pumping energy than we expected, but we had been conservative enough with the design that we weren't in a position where we had insufficient flow, which was good. The other thing that happened is we had sort of done all the sizing and selection around a design temperature of 52 degrees, which is what the old system was doing, 52 Celsius for hot water supply temperature. Everything gets to site, they get the equipment started up. We find the equipment won't let us do anything above 47. So we go back to the supplier and say, okay, well, what's going on here? And then, so it turns out the tech, when he was setting up the equipment, commissioning it, he set it to a max of 47 because that is their recommended set point. And this was the first time anybody had communicated 47 degrees as a recommended set point on this particular piece of equipment. Not a great time to be finding out that you have this limitation. When again, we had thought we had done all of this due diligence and many conversations and equipment selections that all said 52. So anyway, that was something we had to deal with. Ended up understanding, okay, the equipment is capable of 52. Why do they recommend this? Mostly to sort of make it easier on the equipment, less wear and tear. So we ended up understanding that better, and actually, I think compromising on about 50 Celsius, we decided we can get away with in most circumstances, and putting some time delays in there where we don't allow the equipment to operate at that temperature for too long, a couple hours before it kind of reverts back to 47. So we kind of dealt with it that way, but again, not awesome to be finding that out after the equipment is installed. Keep going, Omar. Commissioning, I'm not going to do the commissioning process justice here in the time that we have, but needless to say, we spent a lot of time on commissioning. And I would say our budget time-wise for commissioning was probably more than it was for the actual design piece because of how much time we felt it was important to spend on commissioning. And so very long commissioning process. Obviously, the initial commissioning can just kind of get everything up and running, but we're still involved in the building to this day, tweaking and adjusting things. Some of the learnings we had initially is that we had some lockouts in place that were a little too aggressive, so we were finding some mornings, especially in shoulder season. There were some parts of the building that weren't getting warm enough. People were complaining. In the process of trying to troubleshoot some of these cold zones, discovering that there's actually a lot of VAV boxes throughout the building that were not working as they should. They had faults. So that actually ended up providing enough justification that we actually are now doing continuous optimization in the building, because we kind of realized there's all these other sort of not related so much to the heat pump in the central plant, but kind of throughout the rest of the building, enough sort of cumulative problems that doing COP made sense. And the building had previously done COP sort of 8 or 9 years ago. So this was the second round of COP, which is actually right now in the implementation phase. And I guess the other thing I want to talk a little bit about is electrical demand charges being a little bit higher than we wanted. And part of this related to how, so we do have like a hybrid system here. So we have electric boilers, we have heat pumps that need to work together. And what we were finding is we were getting kind of more demand than we wanted. And I made Omar just kind of advance the slide here. So just, I want to get into this because I know everyone's hybrid systems are a big topic of conversation, something I previously talked a lot about. But so just to kind of point out the issue here is one of the things we found is, so this is the demand for a late November day. This is this past November. So you can see the demand for the day peaks right around 6 a.m. this is sort of kilowatts per hour in hourly chunks. So more or less, you're seeing peak demand. So, around 600 kilowatts kind of at 6 a.m. But what also happens at 6 a.m., if you go to the next slide, and so well, why is it at 6 a.m.? That happens to be, so if you look, this is a trend log from the building automation system. That black bump, which happens to be right around 6 a.m., is the boilers coming on. So the way that we designed the strategy was to basically say, okay, we can use the heat pumps as much as we possibly can, and then we'll only bring the boilers on if the heat pumps can't keep up. But what we were finding is that that was happening kind of at a time when other things were also starting up in the building. Uh, and we were creating a big problem for ourselves. So we were actually creating that demand spike and exacerbating the demand spike by the boilers were deciding to come on because that was the way we had it programmed. Sort of around 6 a.m. is when they decided. The heat pumps usually started up a bit before, and then if there was a determination that the heat pumps weren't heating up fast enough, then the boilers would come on. And all that was happening at the same time. A bunch of other stuff was coming on in the building, creating this sort of first thing in the morning demand spike, which is not at all unusual in a electrically heated building, but something we decided to see what we can do about it. So maybe for the next slide, Omar. So in terms of trying to cope with this, and some of these are kind of particular to having an electric boiler and heat pump, but some of the lessons are the same, even if you would have a gas system. And the big thing being like heat pumps don't like to start cold, especially these big air to water heat pumps, especially. They take a long time to come up to temperature. If you're starting from, let's say, 20 degrees Celsius and you're trying to get that hot water up to 50, that's going to take a long time. It's going to take an even longer time if it's cold outside. And the way we had it set up was we were going to kind of let the heat pumps do as much as they could and then bring the boilers on. So what we're going to do instead is actually decide on cold mornings, we're going to kind of jumpstart the system with the boilers. So we're going to bring the boilers on first thing. And we're going to let them do that first initial heavy lift, and then we're going to let the heat pumps work kind of more in a steady state. And that has the benefit of bringing the boilers on even earlier when nothing else is really going on in the building. So we're not going to kind of simultaneously sort of have load coincident with air handling units come on and a lot of other things. People actually showing up and starting their day, so that we can sort of get the boiler piece out of the way, have that demand occur when the rest of the demand of the building is pretty low, and then we'll switch over to the heat pumps, and they're actually going to work much better. Well, that's the theory anyway, because the system is already kind of up to temperature. So that's one approach we're taking. Another thing I saw mentioned in the chat was, well, could you just eliminate the startup altogether? And yes, that is also an option. We just say, we're just going to keep the building kind of warm 24/7 with the heat pumps, and then not, even further eliminate the boiler use. I think that's a viable strategy. Our conclusion so far in this building is that, we're better off still doing a shutdown and a warm up just with all the pumping energy and the extra heat loss from keeping things running. The net benefit is still to do shutdown, optimize startup. But I'm kind of 75% sure about that. I think these are things we're still exploring with and playing. And I think, and certainly in some buildings, I think there would be a case for saying, yeah, keep it running. Don't do the startup. And I think the other thing is that we're not going to use the same strategy all year. So this idea to jumpstart, that's a winter thing when it's cold outside. Shoulder season, we don't really need to do that. The heat pumps, it's warm enough in the shoulder season that the heat pump actually can cope just fine with those warm up temperatures. And I think the thing we're not doing though is just kind of picking, and I've seen this in a lot of systems, just kind of picking a switch over temperature and saying, okay, below 5 degrees, we're going to use the boilers, and above that, we're going to use the heat pump. Because what we've realized is actually very circumstantial. It's kind of that morning cold start thing that's the problem. It's not simply the fact that it's cold outside. Once the building's up to temperature, heat pumps are fine with cold weather. They don't mind that it's 0, -5, even -10. They'll keep working. And it actually is in our benefit to do so, especially with electric boilers. And this building is designed in such a way that the boilers can supplement the heat pump, so we don't have to just purely switch over from one to the other. So we are using both at the same time, but I think our thinking on this is it's much more sort of around this warm up period that we need to kind of manage that optimally. And aside from that, we're really going to go back to just leaning on heat pumps as much as possible, and then just using the boilers when they can't keep up. Keep going. So Project Outcome been operational a couple years right now. Yeah, so far so good. It's generally the message. We were fine with cold snaps. Even I think last winter there was kind of particularly it reached -12 in Victoria, which is unusually cold, and yeah, system functioned fine. And I think Jason, to your and Jal Properties happiness, I think the project was on time, and I think you said even under budget. So
Yeah. And I was going to say that we've only had 3 service calls for the first 2 years of operation. And with the old system, we had that, I think, the first week. So it was pretty much like it's done exceptionally well. We have a couple other heat pumps at 2 other buildings where the service tech is basically lives here, sort of thing. So it's great. It's been really good. And I think, and then also I was going to say we had an issue with the chiller actually in the summer, going down briefly and for a day or two, and the heat pump kept up on its fine on its own, even though we have kind of switched to the chiller as the primary for the summer. And
yeah,
then the other thing is also the comfort in the building has dramatically improved. So I think that's what Brad spoke to before, was there was a few too cold areas during the winter that we started dialing in on, and I think that's what we realized after replacing this main building plant is now it was every time we got an issue, we'd start to look into it and we'd say, oh, it's because the air source heat pump's down. So that's why everyone's cold. But now that we have a reliable main heat source, now we're starting to get into these like zone level issues and starting to rectify those. So the first winter we did have some complaints. This past one, it's actually been much better. So yeah, it's been
yeah.
great.
And I think we saw some energy savings too. I think we've got
We
some.
did, yeah. I don't know if it's on a slide or not,
Yeah,
but
we've got. There we go.
yeah. So on the whole, SES anticipated us saving about 240,000 kilowatt hours a year, and about $22,000, and we ended up saving what do I have the actual amount here? 263,000 in the first year and $27,000. And then we're also now finishing up a COP study. We're sort of in the tweaking commissioning phase of that. And that aims to save a further 281,000 kilowatt hours or 16 grand. So yeah,
Yeah, and that's kind of like 10, not quite 10% of the energy of the
it
building, I
was,
think.
yeah, 9%.
Yeah.
Yeah. And as far as budget goes, yeah, I could speak to some actual, well, rough numbers. The original budget for this project was about 2.3 million. And we came in under budget at about 1.9 million is where we came in, which is about 18%. So, which is great.
Yeah.
Oh,
So I
and
see a question about asking about COP. Continuous optimization. So COP is BC Hydro's continuous optimization program. So it's a recommissioning incentive program they offer. Yeah, this is just showing demand. Again, certainly down from before. I think we've got room to further optimize this and kind of get it down. So,
this is what
but
we're working on now. Yeah.
yeah,
So yeah, we saw huge energy savings, but that was the thing we started to notice that, wait a minute, the demand isn't saving that much. So that's what Brad was discussing before of tweaking that.
yeah, I think we've got room to improve for sure.
Yeah.
Yeah, so I mean, in terms just to kind of wrap up, this is lots of questions, so we'll try to make lots of time for questions and discussion here. But just to kind of emphasize the big points here is like this integrated project team that worked really well. I said I can't stress enough how pleasant it was for us to work. It just the whole project felt less adversarial as a result. I think if there was ever a problem, the problem solving felt very congenial because everyone had been involved in all of the decisions made so far. So it wasn't sort of, pointing fingers like, well, you're the engineer, you designed this, why isn't it working? It was, we'd all kind of designed it together and the contractor had reviewed everything we've done. We had reviewed everything they suggested. So I think that just it was more fun. And I mean, maybe fun isn't something we talk about enough in this business, but this was a fun project, and it was fun because it was good people and a good environment. And I really credit Joel for kind of convening a great team. And it was yeah, there were hiccups, but I think generally speaking, it went off much more smoothly than almost any project I've ever been involved in with this kind of complexity. Um, we use, and I kind of showed this briefly, but using because it's an existing building, because we had a pretty good building automation system, we were able to use actual building data to design and size the equipment to supplement kind of the traditional sizing approach, which is to use sizing software. So that gave us a lot more confidence that we actually were going to get that piece right, and we knew what the building was going to do under different conditions because we could kind of look back on past trend logs and actually see that in the data. And then I think finally just commission. Like we've done a lot of commissioning on this system, and it has been, I think, well worthwhile. I think if we had walked away, a month after installation when it was sort of startup was done and things were sort of working well enough. We would have missed a ton of opportunity. I think we would have had people still be quite uncomfortable. We wouldn't have achieved all of the things that we've achieved. And so I think the commissioning is, I mean, any of you on the call who know me know that I talk a lot about commissioning and its importance. And I think this project has done nothing but bear that out. And then in terms of what I think we used to call this slide, what didn't work, but lessons learned. It's a more happier title. This whole thing with the vendor and the equipment performance, as I said, like we were aware of this, that the equipment might not work quite as expected. And because of that, we had the suppliers there from day one. We had the contractor talking to them. We were talking to them. And yet we were still surprised by some pretty key things when they got to site because they were never communicated to us. And I feel like we asked the right questions, but obviously we didn't ask them to the right people. Because yeah, I mean, finding out that your maximum hot water supply temperature is 5 degrees below what you're expecting is not something you want to find out. Having equipment pressure drops greater than expected is not great, right? So my advice here, and we haven't fully figured this out, and I'm dealing with this in other projects now, but there's like, inevitably when we get into troubleshooting and like it gets like, this is for jobs that are installed, and we're dealing with this on another site right now. It's like, we're talking to the people who install it, and they're like, oh, I got to call the factory and ask this question, like some super technical thing about how a piece of equipment's set up. We're dealing with this on a heat recovery chiller somewhere. It's like, the installers don't actually know that much. They're like, well, we got to call the factory and they've got technical support at the factory. I'm like, I want to talk to that technical support guy in the factory during design. But as engineers, we often don't have a direct pipeline. Like even on this job, which is like install another project, like we have to go through the contractor to get permission to like have a meeting with this person in the factory. But they exist. They're somewhere. But you have to try really, really, really hard to find them. Because usually who you're talking to are the salespeople. And there are some excellent salespeople out there. I don't want to say, there's people who are bad at their job or they're intentionally misleading. I think often they just don't know the information that we need to know. Like this isn't like buying a boiler. There's a lot of like pretty intricate things about heat pumps that you need to understand, especially as a designer, and the salespeople just often don't have that information available. So trying hard to get a pipeline into the factory so you can talk to the people there who actually really understand how these things work, I think is really crucial. So that's something we're going to keep trying harder on future jobs, and hopefully we can build some of those relationships. But I think the other thing we can do is just understand where those critical failure points are and kind of over design them a bit. So we kind of purposefully over designed the pumps. So if we were surprised by pressure drop, that wasn't going to be an issue. I would say on the temperatures, we kind of got lucky that the building was able to handle lower temperatures than what we had wanted under a lot of circumstances. So that didn't end up being as big a deal as it could have been. So, one in our case, one intentionally over designed, one we kind of got lucky. But I think, yeah, have some buffer in your design on some of these key points. Yeah, I think that's it. In terms of material, I mean, there's obviously lots more. I think we've previously done 3 hour plus presentations on this site, so there's lots of things that were glossed over, but it seems to be a pretty lively discussion in the chat and lots of questions. So we have 15 minutes left, so we can get into some of that. I don't know, Omar, have you been kind of keeping your eye on?
I have, yeah. And yeah, we're wrapping up just on time, so we've got about 15 minutes for questions. Lots of questions in the chat, some of which you might have already answered, and some of which are pretty contextual, I think, to what was going on. Matt Crane early on asked about a recommended gallon per minute to ton ratio. I guess that's for the equipment that was retrofit in here.
No, I know. Well, I'm probably not even the right person to ask because I'm not actually a mechanical designer, but I would say it can be very equipment specific, like depending on the kind of compressor you're using. I would say, and I will say on that point, the manufacturers do seem to have a better understanding of their equipment than they did back in 2010 when this was originally done. So I think generally you can count on the numbers that you're provided, but like I would say take those very seriously and maybe even over design a bit. Like, they'll tell you here is the design flow rate, and even the advice. The chiller is a train chiller, and even their advice is they said stay away from variable flow. We want this type of chiller likes constant flow. Fantastic. We'll make sure that we design with that in mind, and to the recommended flow rate that they give us. And same, they'll tell you what the system volume is, and you can do the calculations around pipe length in the building and diameter and figure out how much volume you have, and then decide how big a buffer tank you need or don't need. So I would say, yeah, very much follow the manufacturer's guidelines there, and it never, system volume wise, it never hurts to have some extra. But you don't want to have too much because then it takes even longer to heat up the building in the morning if you're going to take that approach to control. So there is a balance there. But yeah, I don't think I would say there's a particular rule of thumb that you should use for equipment like this. I would say you should talk to your manufacturer and find out what they recommend and make sure you use that.
All right. There's a question early on from Eduardo about whether, and I think Jason, you mentioned this, there was an energy audit done for the building. I guess a few questions about, the amount of glass and whether that had an impact on the equipment's ability to keep up.
I think it definitely did. Brad did the energy audit, so he would probably
Yeah.
know.
Yeah, and I know there were some questions around the design and so yeah, that's why we use the data because yes, there's a lot of glass. This building also, we didn't really touch on it, but it's called the Atrium because it has a giant atrium in the middle of it, which creates some interesting HVAC challenges as well, where all the air kind of comes back to the atrium and that is a feature that needs to be considered as part of the design process. So having the luxury, this is the difference between retrofits and new build is, we have the luxury of some existing operational data. And so we've leaned heavily on that in terms of the design and there's a pretty good automation system that we can mine data out of. So we really did use a lot of that. And even for the energy audit, I use that data to kind of prove out the simultaneous heating and cooling. So when we go to hydro, we can say, yes, here's what we think we can save. And to get, I forget, the incentives were, they weren't huge in terms of an overall project cost, but they certainly, they paid for kind of some of the upgrades, which was the, or paid for a lot of the upgrades in terms of like adding the heat recovery feature to the heat pump and doing a high efficiency chiller rather than kind of a standard efficiency chiller.
All right. Question from Roberto. Was the contractor okay with Joel buying the equipment directly? You mentioned that early on about a way to sort of, move things along. There's often a markup involved. So yeah, just wondering if that was an issue at all from their perspective, Jason.
They were. So I think that also speaks to our relationship with the contractor as well was quite good. We have a well-established relationship with them. And in this case, the Train was the chiller manufacturer, and we also worked directly with them on other projects, and for maintenance and whatnot. And then Olympic was a different manufacturer that we haven't worked with before, but yeah, our contractor was fine with it. So in this case, we've worked with them for 30 years. They know they're going to be maintaining this for the next 30 years. So they don't need that 10%, that badly. So
Yeah, I think that's where the big picture thinking really makes a difference in projects like this, right? I think that's where everyone can kind of understand what the best solution is, and no one's as worried about, yeah, a few percent here or there on equipment markups and things like that.
exactly.
All right. There was a question, and I want to jump to it because it occurred to me as you guys were presenting, why a chiller and a heat pump? Why a decision to use a chiller during the summer months?
I know operationally we wanted it as a backup was the big thing, but then interestingly enough, I was also surprised to find that we would actually use it in the summer, but it was because SES's team there determined that was actually the more efficient way of going in the summer. So
Yeah, the chiller is quite a bit more efficient in cooling. Like this building has a decent cooling load for this area, especially for Victoria. I mean, often you don't have a lot of big cooling loads, but again, because of the glass part of it, but also just the nature of the tenant. I mean, Ferries has a lot of equipment in there. Um, and so there's a pretty big cooling load, so it's more efficient. And I think, the message we heard early on from Gel Properties was we want the cooling to be bulletproof. And we have a lot of these train chillers, and we really like them, and we want you to put one in because we really like them, and we know we can count on them. And I think there was maybe not as much trust on the heat pump. I think this was, obviously didn't have a piece of equipment like this in your portfolio, and I think there was a bit of nervousness around relying on it solely for the cooling, especially given the history in the building where cooling has been an issue. So I think that was just a decision Joel made to say, we're not messing around with the cooling. We want to yes, you can do your heat pump, but we're going to make sure that this building has cooling one way or the other.
yeah, I think it also enabled us to size the heat pump slightly smaller because
Yeah, that's right. Yeah,
because we got the size to the heating load. So
that is an excellent point.
Yeah, Dami, who might have been with SES at the time, actually chimed into the chat speculating that the heating load wasn't as big as the cooling load, so that might have helped with optimizing costs for the equipment because we could, have a smaller heat pump for the whole system.
Yeah, I mean, it's no question it's more expensive to do a heat pump and a chiller. Like, we definitely didn't save money doing that approach. I mean, yes, the heat pump may have been a little bit smaller than it would have been otherwise, but I mean, install costs and all those are the same. So while that may be true, I don't want to give the impression that that decision saved any money because it definitely didn't.
And I saw another question about was the general contractor or the mechanical contractor part of the design process? And the mechanical contractor was. So our controls contractor is the ITC does sort of controls and mechanical maintenance. This ended up being a large piping job. So we brought in Herb Mechanical as well. And that was sort of once we had kind of a rough idea of what we want to do and a rough design, then we sent it to them. Then we brought them into the team as well. The general contractor, luckily, we actually have our own contractors in-house with Joel, which is great. So on the design side, it was our operations team and myself and another person here were involved in kind of the design. And then once we were ready to start building or anytime we had questions on it, then we would turn to our contracting team. So
yeah, you had your own construction management, all that
construction management, I guess, is what they call it. Yeah.
Yeah, there wasn't really a traditional GC on this project. It was, I think, ITC, I think, was the closest to that because I think they were sort of the lead contractor, as it were, but a very kind of unconventional arrangement, but one that worked very well.
All right. Got a lot of questions still filtering in, but Anna Young seems to have put her finger on the magic button. If you turn on your camera and ask your question in person, you might get bumped to the line. So, Anna, did you have something to add your voice to this conversation?
I'm not sure that I do. I've asked so many questions that I'm not sure where we are at. Was it the one about having an atypically high cooling load for this kind of building? I'm super interested in the energy modeling.
Yeah, so we didn't do like a traditional energy model. So we really leaned on the data from the building automation system. So we essentially looked at, okay, well, what is the equipment doing now to service the loads? And looking at so it's essentially virtual metering on the heating cooling systems to get those in real time. There was a bit of an energy model built as part of the we use carrier HAP software, which is a traditional mechanical. A lot of mechanical designers use it, but yeah, you input like wall area and type of glazing, and it's certainly not as sophisticated as a sort of pre-construction energy model we do, but we more use that as a check to make sure that the building automation system wasn't giving us like totally unreasonable values. But generally speaking, we actually design. Term I've used for this in the past is data-driven design. So using data as part of the sizing process, and I think for retrofits especially that works because you have access to existing operational data. So we did make use of that mainly as part of the sizing process.
And I should say on the operational data, we because traditionally it doesn't save it for more than a set period of time. We can't save, but we upgraded to the copper cube system at this building to start storing long-term trending data. So we did that once we saw kind of the writing on the wall with this heat pump, which was about 2 years before sort of we got really into the design. So we had a little bit of data. We didn't have right back to day one. But
yeah, but good enough. I mean, really what we want is we want to see it sort of throughout different conditions. So as long as we've got kind of the core heating season and the core cooling season, we can get a pretty good sense of what the equipment is doing. And then, and we can sort of extrapolate and interpolate to fill in any missing gaps there. But yeah, again, thankfully there was that decision made that made that data available. Because often we're going in, that's not available, and then we have to ask, okay, well, can you install metering? And then you're waiting for enough data to be collected before you can start doing some of this, and often that then conflicts with project timelines, and your best intentions of using data kind of go out the window, and you kind of end up having to approach it the traditional way.
So another thing I would also recommend, now Delta has a product called IntelliVault, which is a cloud-based data storage, and it's actually quite cost effective rather than putting cubes in every building. So we've upgraded our whole portfolio to that, and now we have long-term trending everywhere, which is awesome. So, and it'll make one of these retrofits in the future much easier.
Nice.
Yeah.
Jason, this might be an opportunity for you to channel the collective JAWL brain trust, but there's a question, I guess, now that you've had it, operating for 25 years, would you design this kind of building again to own and operate? The glass atrium, it looks great for the lighting into the interior, but given all the other considerations to owning a building, what do you think JAWL's thinking is about the atrium and the sort of wisdom of that original investment?
I wouldn't dare speak for our investments or our construction side or the design. I know I can tell you from experience, I'm currently sitting in our newest building that also has a large atrium beside us. So if that's any indication of how we feel about it, this one's called the Rotunda. It's not quite as big design, but it's a very similar design to the atrium. So I can tell you, at least when we started designing this one 6 years ago, that we still liked it. So yeah.
And that's where JAWL has its offices. So yeah, you're
And that's
putting
where our office is. Yeah,
putting your
exactly.
people where okay, that makes
Yeah.
sense.
Yeah.
And you've got heat pumps, I think, in that building too, don't you?
We do.
Yeah.
Unfortunately, not an air max heat pump. So.
All right, a couple of final questions as we get to the end of our time. There is a poll throwing itself up there, so if everybody can answer, your feedback is really valuable to helping us make sure that these sessions are, on an ongoing basis, really informative and useful for the building decarbonization community. Jason, could you estimate what the overall reduction in service costs and complaints have been since the new system's gone in? You mentioned kind of like the 1 month, or sorry, 1 week to 1 year, but how much more reliable and effective has this been?
I would. I'm reluctant to. I couldn't put a number on it. I could tell you yeah, it was a lot. Like I would be reduction in service is like 95% or not. Like we literally go down to 3. So, for example, in the building I'm currently in, I do about we have a service tech here. I think he might be here right now. So there's we have them monthly, kind of like we have at least 3 or 4 a month service calls. So extrapolating that out, yeah. So as far as costs go, considerably less. We are under warranty still on that other heat pump, but we haven't had any major failures, and it's been 2 years. And in that same amount of time at one of our other sites, we'd already spent about $200,000 on stuff, so considerable savings. So
Right. Potentially last question, and I know that you love to talk about this, Brad. So, any additional details about the lesson learned from the commissioning of the building? Any insights that it provided specifically that you can share?
I mean, that's a whole other presentation probably, but I think so. One thing is like, yes, we were doing a central plant replacement, but like that central plant is connected to the rest of the building. And I think the thing you need to like assume going into these projects is that you're probably going to have to deal with the rest of the building in the process of making the heat pumps work. And that turned out to be the case here because, you know, as we were starting to get into diagnosing comfort issues and things like that were impacting how often we had to run out the heat pumps and the kind of lockouts we put in place, you know, realizing that a bunch of the issues are actually due to, you know, failures at the zone level. And so then, okay, and so in order to get the most out of the heat pump, we actually have to correct some of those other issues in the building, and every building has those issues. So I mean, you almost just might want to assume from the get-go that you're probably going to have to pretty much recommission the whole building as part of if you're doing a major central plant upgrade, and especially if you're switching from a conventional source to a heat pump. I would just assume you probably want to recommission the whole building as part of that process. And so, and I think that expands because often we think about commissioning and scope of a project being, well, get the equipment up and running, make it work. But we're actually talking about, you know, the whole building here, and a process that really should extend at least a year to kind of cover heating, cooling season and all the shoulder seasons, and potentially longer, as you sort of uncover more issues. So.
All right, well, that's time. You could have just teased that there was going to be a part 2 where you talk for commissioning for an hour, but that was great. Thanks, everyone. Appreciate your time, and thank you to Brad and Jason for digging into this project and sharing your learnings. Yeah, hopefully you've had a chance to fill out the poll, and we will see you again at our next session.